Hi friends, welcome to the channel Unshackling Sudokus and Puzzles. Ashish here, and today I'll be covering a puzzle genre called Arithmetic Square Puzzle. So this puzzle comes into the casual puzzle category, and this puzzle was featured in the recent Puzzle Ramayana contest authored by Madhav Sankaranarayanan. So I really thank the author for giving me an opportunity to cover a video on our channel, and so the contest is over now. It was a really excellent contest. All the puzzles were purely logical, and it was a quite tough contest, but I really enjoyed the contest, and I didn't solve this puzzle during the contest. So I solved this post contest, and I was really happy solving this puzzle. I really enjoyed the logic in this puzzle, and I have never covered a arithmetic square on our channel before. So I thought this would be a really an excellent puzzle to cover on cover this puzzle on our channel, right? So before going to the puzzle, I would highly recommend you to please subscribe to the channel Unshackling Sudokus and Puzzles if you haven't done so. It will really motivate us to cover videos on regular basis. And if at all you have a request for any Sudoku variant or a puzzle genre, you can let us know in the comment below, and we'll surely make a video on it. And now coming back to this puzzle, so there were 3 arithmetic square puzzles in the contest. So the other 2 puzzles were of lower grid size. This is one of the bigger one. Usually whatever arithmetic puzzle I have solved, arithmetic square, those were of digits from 1 to 9, but seeing this puzzle of 1 to 16, I thought of not trying in the contest, and because I still didn't have time to complete all the puzzles, but I must say this was really an excellent puzzle. So let us try to solve this puzzle. Before going to the puzzle, let me explain you what are the rules of this puzzle. So you have 16 cells given here, right? 16 squares. All of these 16 squares will have digits from 1 to 16 in any order without repetition, right? So you'll have exactly 1 to 16 digits here in any order. Apart from that, you can see that there are some I mean to say signs, operations here, mathematical operations, and those will have to be fulfilled while using the digits. So whenever you use 1 to 16 digits in any order, all of these, there are exactly 8 equations here if you see here. So this digit divided by this and this would give you 1. So this digit subtracted by this and this will give you 0. So when you add these 2 digits, divide by this digit and add this digit will give you 15. So there is no particular order here, but the order is from left to right or top to bottom in like I would say there is no precedence here. You don't have to use the multiplication first then the division, nothing like that sort. You just have to go in order from top to bottom or left to right, right? So when you add these 2 digits, divide by this digit and add this digit, you will have to have 15 here, right? Nothing else. So very easy rules, and with that let us try to solve this puzzle here. So the one thing that I saw in this puzzle, the moment I saw this puzzle after the contest, the one thing that I realized is these 4 digits would give you the multiplication of these 4 digits would give you 195. So what I deduced from this is the digits can only be 1, 3, 5 and 13. So let us assume you have 13 as one digit. Of course 13 cannot be factorized into any more digits here. So you have 13 is one digit, 3 and 5 can be combined as one digit, 15. 3 into 5 is 15. So let us assume you have 13 as one digit, 15 as one digit. Third digit can be 1 because multiplied by 1 will still give you the same number. What can be the 4th digit? Of course 4th digit is not possible, so which means the 4 digits will have to be 1, 3, 5 and 13 in any order. So we don't know the order yet, but it has to be 1, 3, 5 and 13. The next thing that I saw is again you have these 4 digits and multiplied will give you 1584. So I did was I factorized these 1584 and I got the digits as 2, 2, 2, 2, 3, 3 and 11, right? So the factorization of 1584 was nothing but 4 times 2, I'll just 2, 3, 3 and 11 here, right? These are the factors for 1584. Okay, so of course we know that 11 cannot be factorized anymore, so 11 would have to be in one of these 4 cells. So we have already deduced that 5 digits are for sure. This row will have digits 1, 3, 5 and 13. This row will have a digit 11 somewhere. Of course we are not sure where it will be, but we know it has to be somewhere, and the other 3 digits would have to be some of these factorizations that we have already done. You can have 4 and 9, no, you cannot have 4, you can have 8, 2 and 9, you can have 6, 8 and 2. There are many other digits that are possible after 11. We are not sure which, but yeah, of course. So 11 is for sure in these 4 digits. Next thing that I saw was, okay, yeah, you know that this digit divided by these 3 digits would have to have 1. So which means this digit would have to be the highest digit here. And 13 will never be part of this digit now, of course, right? So this divided by 13 and then divided by any more 2 more digits would give you 1, which is not possible if you have a 13 in the cell. So 13 would have to be somewhere in these 3 cells. If you don't have a 1 here, the next 3 minimum digits in these 3 cells would have to be 2, 3 and 4. When multiplied these 3 digits, you get the answer as 24. So you know that 24 divided by 3, 2 and 4 would give you 1 here. Of course, but you know that the digits that are used here in this puzzle is 1 to 16, which means you cannot eliminate 1 from this cell. 1 would have to be this, right? Because the moment we eliminate 1 from this cell, 1 would have to be in one of these 3 cells, and these 3 cells would have to be 2, 3 and 4, of course. So which means this cell would have to be a 1 here. Amazing. Again, same thing. What happens if you have a 13 here? This digit subtracted by this and this would give you 0. So let us assume the maximum digit here is 16. If you have a 13 here, these 2 digits would have to be 1 and 2. You already have a 1 here. So 1 cannot be used anymore. So 13 cannot be here. It has to be 3 or 5. Amazing, right? Okay. One other thing that I saw was, when you already have 11 used in these 4 cells and a 13 used in these 2 cells, the minimum digit for the 53, the sum of 4 digits to get a 53 would surely have a 16 and a 15 here. So let us assume you don't have a 16 here. The other maximum 4 digits would have to be 15, 14, 12 and 11. That gives you 40, 52. 15, 14, 12 and 10. I'm not 11. 11 is already used. 15, 14, 12 and 10. That gives you 51. Which means 16 will surely be used. Let us see if what happens 15 is not used. 16, 14, 12 and 10, right? 16, 14, 12 and 10 will give you 52, sorry. 16, 14, 12 and 10 will give you 52, which means 15 is also used. Now we know that 15 and 16 is used in one of these 4 cells, which means the other 2 digits would have to be 14 and 8 or 12 and 10. Right? You will either have 14 and 8. So I'll write here for 53 it is either 16 and 15 for sure, and for this either it is 14 and 8 or 12 and 10. These are the 4 digits would have to be used. 16 and 14 is for sure either 12 and 10 or 4 and 8. Okay, so let's see what happens here. One more thing is, when I factorize 2200, there are a few digits that I got here, which is 2, 1100, 550, 275. Then I got 5, 5 and 11. These are the factors for 2200. But of course, we cannot use these factors here because you have a addition in between, right? So these 2 digits will be multiplied by with the addition of these 2 digits to get 2200, right? But let us see what are the bigger digits that we can use here. The maximum that you can get with the summation addition is 31. Let us assume you get 31, 70. Of course. So which means if you factorize 2200, if you see perfectly, if you use 16 plus 14, 30, maximum you can get 31. 16 plus 15. Of course 15 is not here, so 13 plus 16, that is 19. That is 29, which means the sum of the multiplication of these 2 digits will have to be at least 70. Just going by the calculation, if you have at least 70 when these 2 multiplied, you can get to the answer 2200. Anything less than 70 will never give you the answer as 2200, which means 7 can never be used in these two cells. It has to be something more than 7. No, 7 can use 7. So 7 can be used, but 7 is not a factor of 2200. 8 is a factor. 9 is not a factor. 10 is a factor. 11 is a factor. 12 is not a factor. 13 is not a factor. 14, 15, 16. Yeah. So you have only 3 factors here. That is 8, 10 and 11. Of course. So these 3 digits can only be 8, 10 and 11. What happens if you don't use the 11 here? 8 and 10. 8 into 10 is 80. 80 doesn't go with 2200 perfectly. So which means 11 would have to be in one of these two cells. And you know that 11 is in one of these 4 cells. So 11 would have to be here. Right? Of course, this cell would have to be 11. And now we know that either 8 or 10 would have to be used here. So if it is 8 here, you will get you already have 1000. You already have 220 here. No, yeah, you already have 200 here. So if it is 8, you will have sum as 25. If it is 10, you will have sum as 20, right? So the sum is either 25 or 20 if you use 8 or 10. Okay. Okay, so let us leave for that now. We know that, of course, that is an excellent logic here that I forgot to use. You know that these 4 digits are either 16, 15 with 12, 10 or 16 and 15 with 14 and 8. Where can a 7 be used? You have a 7 in this digits, right? 1 to 16 you have a 7. 7 is in none of these 4 cells. 7 is none of these 4 cells. You have 11 used here, and the factors of 1584 are 2, 2, 2, 2, 3, 3 and 11. So 7 cannot be used here. 7 is in one of these 3 cells. Amazing, right? Now if you see here, where can you use 14? Again, because why am I taking 14? Because 14 also has factors as 7 and 2. Where can you use 14? 14 can be used in this row. Of course, 14 cannot be used here. 14 cannot be used here because some of these 3 digits can either be 16 or 20. So if you have 8, some of these 3 digits would be 16, divided by 8 would give you 2. Some of these 3 digits, if it is 20, divided by 10 would give you 2. So whatever be the case, 14 cannot be used here because the sum will be more than 16 or 20. And 14 cannot be used here because we don't have a factor as 7 here in this 1584. So which means 14 would have to be in one of these 4 cells, and the digits here are 14, 8, 16, 15. You got 14, 8, 16, 15 in first row, 1, 3, 5, 13 in second row, 7, okay, 8 or 10 in third row. Okay, 8 is already used here, so this cell would have to be a 10 now. So which means the sum would have to be 20. So if it is 13, it is 7, not possible. So 13 would have to be here. This is either 3 or 5 to get the 20. If it is 3, it would have to be 17. So 3 is not possible. It is 5, 15 and 3. Okay, so if this is 10, the sum of these 3 digits would have to be 20. 7 is already used. You will need 13 more. So sum of these 2 digits would have to be 13. It cannot be 1. So what are the other digits here? 2 and 11 is not possible. 3 is not possible. 4 and 9 is possible, right? 4 and 9 is possible. Let us write that here. 4 and 9 is a possibility. 5 is not possible. 6 and 7 is not possible. 7 is already used. Again, 7 and 6 is not possible. 8, 5 is not possible. Okay, of course. So the only digits are 4 and 9. So it has to be 7, 4 and 9. And we get the digits directly now. The other 3 digits would have to be 11, 2, 6. 2, 6 and 9, right? No. 9 is already used. 10, 11, 12. 2, 6 and 12. Yeah, so you'll have 2, 6 and 12 here, and we have already got the digits here. It's just about how you place to get the equations done here. And of course 12 cannot be here because then the division won't be fulfilled, so 12 cannot be here. 12 also cannot be here because then you cannot have the subtraction as well fulfilled, because you cannot have a higher digit here. So this cell would have to be a 12. So this, which means the equation till this 3 digits would have to be 3. Sum of these 2 digits divided by this digit would have to be 3. And so to get the 3, it is either 14 here and 9. 4 is not possible here, of course. You already have 13 divided by 4 is more than 3. So if you have a 7 here, it would have to be 8. If you have a 9 here, it would have to be 14. Okay, where can 16 be then? If it is a 16 here, you'll have, okay, if you have a 16 here, this equation cannot be fulfilled. You'll have to have 8 and 2. The only possibility is 8 and 2. 8 is already used here, so which means 16 would have to be here. That is 3. You need 13 more with these 2 digits. That is 7 and 6. That is 9 here, 4 here. This 9 gives you a 14 here, and that gives you 8 here and a 2 here. Amazing. So with that we have solved this arithmetic square puzzle. Amazing puzzle, I would say. If you see here, let us see if the equations are correct now. 8 plus 16 is 24, for 38 and 53. Of course the sum is done. 1 into 3 into 13 into 5 is 195, correct. 4 plus 7 is 13 plus 9. It has to be 20. Oh sorry, 4 plus 7 is 11 plus 9 divided by 10 is 2, right. 2 into 6 into 12 into 11. See, if you have 11 here, these 3 and 2 would give you 6. This is a 2 and multiplied by these 3 digits would give you 12. Amazing. This equation is also done. This equation is also done. 27 divided by 9 is 3 plus 12 is 15, done. 16, 3 plus 7 plus 6 is 16, done. And yeah, exactly. So what an amazing puzzle. I hope you enjoyed this arithmetic square puzzle, and I hope you got to know how to actually solve our arithmetic square puzzle. So I really thank Madhav Sankaranarayanan for such a wonderful puzzle. I hope you enjoyed this video. Do like and comment if you want us to solve any other Sudoku variant or a puzzle genre, and don't forget to subscribe to the channel. Thank you.